Hello, howdy. I hope you're having a great day. That is very good. Now, still on redox reaction, that is oxidation and reduction. What we want to look at in oxidation and reduction here is the balancing of ionic equation. Balancing of ionic equation in redox reaction. We are going to look at how we balance the ionic equation in acidic medium and in basic medium as well. We are going to look at the two together as we are going to know how to balance this equation. I hope you are going to take your time, relax yourself, and let's see the way we are going to do this solving. And the method of approaching this kind of a question is very easy. Let's go. Now, I have a question here. The question says that we should write the balance ionic equation for redox reaction between acidified heptaoxodichromate 6 ion and chloride ion. Now, I want to write the formula of those compounds that are mentioned there. I want to write them out. Those ions. Heptaoxodichromate 6 ion will be like this. Cr2O7 2-. It is an ion. Then the chloride ion, this is chlorine. Now, this is the two reactions, or this is the two ions that we are asked to write the so-called ionic equation that occur in between them. Now, the steps we are going to follow in writing this ionic equation are as follows. Number one steps is that you are going to write the way those ionic equations are going to be converted into either their atoms or their ions. You are going to write it out first. The two of them, let them convert. They are in ion forms here. They have to convert them into. You have to show us the product which they lead into to get their atoms. Let's see how we are going to do that. I need to round this now. Now I have this Cr2O7 2-. That is the heptaoxodichromate 6 ion. So this will lead to Cr3 plus to Cr3 plus. It is leading to chromium ion. See, now this is aqueous medium. In aqueous medium, it is in solution, and we have the Cl minus. We give us Cl2. That one gives us an atom, which is a aqueous medium as well. Aqueous. This is an atom. So there will be two here. So 2 Cl minus leading to Cl minus. That is the first step you are going to take there. Number one step is that you have to first of all show us how they are going to lead into their either ion or their atom form for their product side. That is what they are going to form in their product side. Now, let's now look at this again from it. I've been able to write the product which they are going to lead to. You will be arguing it with me that there's oxygen here. Where is it? You'll still see where you are going to see the combination of oxygen is going to show. What you need to take note here is this. Look at the oxidation number of chromium here. Compare it to what we have, the oxidation number of chromium here. The oxidation number of chromium here is 3. While the oxidation number of chromium here is 6. How do I get 6? You know, from the name, you call it heptaoxodichromate 6 ion. So oxidation number of chromium is what we put in that bracket. And you can as well calculate it this way to be 2Cr. No, oxygen is minus 2. Minus 2 times 7, that's minus 14, is equal to minus 2. That's the charge on it. We have 2Cr is equal to 12. Cr will be equal to 12 over 2, which is equal to 6. That's how we're able to get the oxidation number of chromium here. Let's stay here. And don't forget that oxidation is a process of loss of electron, which will lead to what? Increase in oxidation, decrease in oxidation number. Oxidation leads to what? Loss of electrons, sorry, leads to what? Increase in oxidation number. While reduction is what? The gain of electron, which will result into what? Into the gain of electron and will lead to what? Reduction in oxidation number. So what happened here is what? This process undergo what? This is where you're going to have reduction. And this is going to be a what? Oxidizing agent. Oxidizing agent. That is our oxidizing agent. Cr2O7 to minus is our oxidizing agent. And you can see this one as well too. The oxidation number of this chlorine here is -1. Why the oxidation number here is going to be 0? Because it is in its neutral state. The oxidation number of chlorine here will be 0. So in that regard, now this one is -1 is 0. So it has increased. And what is oxidation? Oxidation is what? Loss of electron, which do what? Leads to increasing oxidation number. Loss of electron. What happened to the electron? What the electron has been lost. What leads to what? Increase in oxidation. Oxidation number is increased here. This is oxidation process. And this is what? Reducing agent. So you have to take note of that very well. After you take note of that very well, you'll be able to know how to go ahead with the remaining set of reaction. Now, the step 2. The step 2 that you're going to take there. Now, what you do is this. You now look at the reaction from both sides now. Let's look at the oxidation of reaction now. That is reduction of reaction, reduction of reaction. Reduction of reaction. Reduction of reaction. That is for the chromium, Cr2O7 2 minus aqueous, which give us a Cr2Cr3 plus. Now, after you've seen this, you've been able to write this out. Why I leave a little space here is that there are some things that we have to bring out there. Now, because we are in acidic medium, we are dealing with the redox reaction in acidic medium. You have to add to the two sides where you are going to have hydrogen and water. That is what you add to the two sides. You add appropriate number to the two sides. Definitely, when you add hydrogen here, when hydrogen combine with oxygen here, it will definitely give us water here. So we are going to add appropriate number of hydrogen. This is hydrogen here plus water, H2O. So let's now balance the equation. After you have added the two together like that, what you do next is to balance the equation. Now, we have hydrogen here 2. This one here is not balanced yet. So in that regard, I have to look at how to balance it. We have 7 oxygen here. No oxygen here again. So what if I put 7 here? Yes. So oxygen here is going to be 7 now. But we have hydrogen has turned to, that's what, 1 mole of hydrogen H2 times 7, that's going to be 14. So I'll put what here? 14 hydrogen here. So let's look at this equation very well now. We have 2 chromium here, 2 chromium here. Oxygen is 7 here, it's 7 here. Hydrogen is 14 here, it's 14 here. The equation has been balanced very, very well. So that is a very good balancing of the equation. Now, the next step you are going to take is that you have to balance the charge on the either side. You have to balance the charges on either side. You look at the charge you have there, then you balance it on the either side. This is H plus, this is hydrogen ion. That is how you balance it. That is 14H plus. Now, you have to balance the charge on the other side now. Now, from the left hand side now, or the reactant side now, the balancing of the charge will be what? This is what? We're having -2 here. -2 plus, this is what? 14. 14. Then on the right side here, that is the product side, you have the balancing of what? That's going to be what? Just 3. That is a 3 times 3. Our right hand side is going to be 3 ion here multiplied by 2. So that's multiplied by 2. This is the 2 here. That's going to be equal to 6. So now when we have it here, minus 2 plus 14, that's going to be what? 12. And the right hand side to be what? This is 6. You can see we're having 12 here, 6 here. When you subtract this 6 from this 12 here, which means we are still going to have 6 of this one that will be here left in the left hand side. In this regard, you are going to bring in electron. No more electron here because you have used this one. You have bring this one here, subtract this particular electron here from here. This is electron. So you're going to have it to be what? Cr2O7 2 minus plus 14 hydrogen ion plus 6 electron will give us, you can see, I'm bringing in this electron now because this is 12. When you subtract 6 from 12, it will remain 6 here. So this one will not be, there will not be anything here because you use it to remove, subtract from one another. Plus 2Cr3 plus 7H2O plus 7H2O. That is the what we have for this reduction of reaction. Then the next thing we do is that we move to the oxidation of reaction. Let me move there. Oxidation of reaction. Now, in oxidation of reaction, you are going to bring in this. Don't forget that I've been able to show you that this is oxidation reaction because it leads to what? Loss of electron, which leads to the what? The gain of oxidation number, increase in oxidation number. Now, we are going to look at that reaction. Now, we have this 2Cl minus. This is what we have here, which leads to what? Which leads to Cl2, chlorine atom there. There is no ion on it there. Now, you look at it from this angle that. Now, looking at it from here, the number of atoms we have there are balanced each other. If you look at it very well, the number of atoms are balanced each other. So there's two atoms of chlorine here, 2 atoms of chlorine here as well. It has balanced each other. Now, what you need to do next is that you now balance the charges. Don't forget, when you look at the atoms, balance it first. Then you look at the charges, and you balance it as well. Now, if you look at the charge on the left hand side, we are having minus 1 times 2. That's what? 2. This one is what? 0. This is what? 2. This is 0. Ignoring that negative sign there. So, in that regard, you are going to have 2Cl. You know, evidently, when you subtract this, you are going to need 2 electrons here for it to balance each other. Don't forget what we did here. What we did here is that we bring this one down here, subtract it, then we make it to be balanced here. So we are going to have 2Cl minus will lead to what? Cl2 plus 2 electron. Cl2 plus 2 electron. The next step now, step 3. The next step, that's step 3, is that what you do here is that number of electron lost must be equal to number of electron gain. The number of electron lost, take note of that, must be equal to number of electron gain. So in that sense, what we are saying there is that when we are trying to do the reaction together, when we want to put it together, look at the reduction of reaction, we can see that we have 6 electrons there. But in the oxidation of reaction, we have 2 electrons there. So this one is at the product. This one is formed at the product side. This one is formed at the reactant side. So this one is the one that is lost. And it must be equal to number of the one that will be gained again. So in that regard, this electron here must be multiplied by a particular value that will turn into what? 6 electron here. So which means that everything here, you now say, multiply oxidation of reaction by 3. So we are going to have 3 multiplied by 2Cl minus, which gives us a Cl2 plus 2 electron. So this will be equal to 6Cl minus, giving us 3Cl2 plus 6 electron. Now, that one has balanced it properly now. You can see that we have 6 electron here. This is the what we form at the product. We have 6 electron at the reactant side from the reduction half reaction as well. Now, number of electron in oxidation and reduction are the same. Now, you can see that the oxidation and reduction, the number of electrons that we have there, they are now the same. What you need to do now is that you will now add the two reactions together. You will have the two reactions together. Now, when you want to add the two reactions together, you bring this one. This is what we have at the reactant, which is going to be what? That's step 4. Add the two reactions together. Add the two reaction. Add the oxidation reaction and the reduction half reaction together. So we're going to have Cr2O7 2 minus plus 14H plus 6 electron. What do you have here at the reactant side? 2Cl plus 2Cl minus. We give us 2Cl3 plus 2Cl3 plus 7H2O plus 6 plus 7H2O plus 3Cl2 plus we have what's the plus 6 electron. So this is what we get here now. If you collect the like terms, this is only the like terms there. When this one comes there, it becomes minus 6 electron. So we are going to have the final. So to be Cr2O7. Definitely, this one will cancel each other out. Collecting like terms, collect like terms. Cr2O7, 2 minus plus 14 hydrogen ion plus 2Cl minus will give us 2Cr3 plus 7H2O plus 3Cl2. 3Cl2. It's very easy to do. You can see how I've been able to simplify it with ease for you. So I hope you are going to stay tuned to our class to have access to more of this easy way of solving this question. Look at the way I've solved it. You can as well do it on your own. See you some other time. Thanks.